Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this video, we are going to learn Chapter 9, Managing Project Quality. Okay, this chapter will focus on the philosophies, processes and tools for project quality management to develop a project quality management plan. Okay, these are the learning objectives of Chapter 9. So after watching this video, you are supposed to be able at least apply the quality concepts, methods, and tools introduced in this chapter to develop your project quality plan. Okay, what is quality? Basically, quality can mean different things to different people, right? So in our case, it is important not to define quality only in terms of features or functionality, right? The dictionary defines quality as an inherent or distinguishing characteristic, a property, or having a high degree of excellence. Okay, so in business, quality has been defined in terms of fitness for use and conformance to requirements. Okay, fitness for use concentrates on delivering a product or system that meets the customer's needs. Okay, while conformance to requirements or fulfilling requirements means it's more on meeting a predefined set of standards. Okay, project quality management. PMBOK guide defines project quality management as the processes and activities of the performing organization that determine quality policies, objectives, and responsibilities so that the project will satisfy the needs for which it was undertaken. Okay. This figure provides a summary of project quality management concepts discussed in this chapter. Okay, we start with quality management planning, which begins with defining the quality standards in terms of grade and tolerances for quality. All right. So basically, quality management planning requires adequate time and budget allocated in the project plan for testing and other activities to ensure the project team is building the right product or system and they're building it the right way. Okay, so all of the quality standards along with the processes, metrics and tools to determine whether these standards are met are documented in a project quality plan. Right? Okay, next is quality assurance. On the other hand, quality assurance focuses on auditing or defining a set of checks and balance to ensure that the project team is following the processes outlined in the quality management plan and that metrics are being collected and analyzed as part of quality control. In quality control, project team will collect data to analyze performance and make changes as needed to ensure acceptance of project deliverables. So, by following the quality assurance and quality control activities, the project stakeholders should reflect and document lesson learned. Right? So this can lead to continuous improvement by identifying the best practices and improvements to the quality management planning processes. Okay. The activities of project quality management should focus on both the project deliverables and project processes. Okay. From our point of view, the project's most important deliverable is the product or system that the project team must deliver, right? So the product or system must be fit for use and conform to specified requirements, which is outlined in both the project scope and requirement definition. Okay, and more importantly, the product or system must add measurable value to the sponsoring organization while meeting the scope, schedule, and budget objectives. Okay. For example, business case, project plan, the IT solution, etc. So the project processes, we can also view these processes as part of a quality chain where outputs of one process serve as inputs to other project management processes and phases. Okay, which is by focusing on both the product and chain of project processes, the project organization can use its resources more efficiently and effectively, minimize errors, and meet project stakeholder expectation. Okay, for example, scope management, risk management, requirement analysis, design, implementation, and etc. Okay, this figure provides an illustration of impact of rework, right? Although the amount of rework may not be linear, it shows that finding a defect becomes more costly as the project progresses. It is due to increase of amount of rework, right? So, for example, if a requirement is not properly caught early during the requirement definition, okay, the amount of rework is minimal because the missing requirement can just be added to the list. However, as the project progresses, okay, the amount of rework will increase, right? So let's assume that the missing requirement is discovered during implementation, okay, or after the application is released. Okay, if this happens, the requirement would have to be defined in terms of developing the user story, to be developed, okay, to be tested, and then to be re-released. Okay, therefore, the cost of a product or system defect may include number one, the time and effort spent by the project team investigating and diagnosing the defect. Number two, the time and effort of redesigning, developing, and retesting the defect. Number three, any additional time and effort if retesting uncovers any new defects. Okay, and the last one, the embarrassment and the loss of goodwill. Okay, if a defect is found by the customer, right? Okay, next is quality philosophies. Okay, this topic will focus on the concepts associated with quality management with a brief history of the people who helped shape this important area, right? This knowledge may help in giving us a better understanding on how to apply the quality concepts and tools when developing a project quality plan. Okay, the first one is craftsmanship, right? It is about a deep knowledge of crafts with high standards and attention to detail to make sure the work done using best materials available. Okay, so the idea of craftsmanship was formalized during the Middle Ages when the quality of products and the processes to produce those products were held in high standard. Okay, guilds were created by merchants and artisans for each trade or craft, right? So these guilds regulated who could sell goods or practice a trade in a particular town to ensure the quality of the product, right? The second one is scientific management by Fredrick Taylor. We will see the details in the following slide. Okay, the third one is the total quality management gurus. Okay, we start with the Edward Demings. Deming's philosophy and teachings are summarized in his famous 14 points for quality that are outlined and discussed in his book titled Out of the Crisis. All right. So Deming's teachings emphasize the value and importance of people to a greater extent than the scientific methods. Okay. Next is Joseph Juran. Juran's philosophy and teachings have also had an important and significant impact on many organizations worldwide, right? So Juran's message on quality focuses on his belief that quality does not happen by accident. It must be planned. Okay. And Joran's view of quality consists of a quality trilogy, which are quality planning, quality improvement, and quality control. Right? So the last one is Philip Crosby. Crosby defined quality as conformance to requirements based on the customer's needs and advocated a top-down approach to quality in which it is management's responsibility to set a quality example for workers to follow. Okay. Okay, now we go detail to quality philosophies in scientific management by Fredrick Taylor. Okay, actually, Fredrick Taylor believed management would set arbitrary rules of thumb. Okay, the earlier situation is workers produce so much each day, no more, no less. Okay, and Taylor believed the production process could be more efficient by increasing the specialization and the division of labor, right? Using scientific management approach, Taylor believed that a task could be broken down into smaller tasks and studied to identify the best and most efficient way of doing it. Right? So the use of a stopwatch as a basis for time motion studies provided a more scientific approach. Okay, but the controversy of the approach is many experts ignored the human factors and believe profits could be increased by speeding up the workers. Okay, and some thinking that the dehumanizing of the workers led conflict between labor and management and eventually laid the foundation of labor unions. Right? So that's all about the quality philosophy. Okay, the capability maturity model integration, CMMI. Okay, what is CMMI? Basically, CMMI provides a set of recommended practices that define key process areas specific to software development. Okay, the objective of CMMI is to offer guidance on how an organization can best control its processes for developing and maintaining a product system. CMMI was developed by Software Engineering Institute at Carnegie Mellon University in 1986, okay, with the help of Mitre Corporation and Watts Humphrey. A framework was developed to assess and evaluate the capability of software processes and their maturity. And the work called the Capability Maturity Model, CMM, but has evolved to the CMMI, which is not limited to a specific area, but can be used across different disciplines, right? Okay, to understand how CMMI may support project quality, several concepts must be defined. Okay, these are the concepts that may support project quality. You can read by yourself, right? The first one is process capability, process performance, and process maturity. Okay, this figure illustrates the CMMI framework for process maturity. Right? Each level allows an organization to assess its current level of process maturity, and then helps it prioritize the improvement efforts in terms of the key process area it needs to have in place to reach the level of maturity. So the maturity levels provide a well-defined evolutionary path for achieving a mature process organization. So there are 5 levels of process maturity. Okay, level number 1 is initial, which is processes are disciplined. Level 2, repeatable, which processes are standard and consistent. Level 3, defined, processes are predictable. Level 4, manage, which is processes are continuously improving. And the last one, level 5 is optimizing. Okay, and this is the key process areas uh, that needs to have in place, right? Level 1, no key processes in place. All right, that's all. Okay, we start with the level 1 of CMMI, which is initial. Okay, the initial level generally provides a starting point for many organizations. All right, so this level is characterized by an immature organization in which the project process is ad hoc and often reactive to crisis. Okay, and it does not have a stable environment for projects, and success of a project rests largely with the people on the project and not the process that they follow. So as a result, success is difficult to repeat across different projects throughout the organization. Okay, and at this level there is no key process areas are in place. Okay, so CMMI level 2, which is repeatable. Okay, at this level, basic policies, processes, and controls for managing a project are in place, right? Project schedules and budgets are more realistic because planning and managing new projects are based upon past experiences with similar projects. Okay. Although processes between projects may be different at this level, the process capability of level 2 organization is more disciplined because processes are more documented, enforced, and improving. So as a result, many previous project successes can be repeated by other project teams on other projects. Okay, so key process areas in level 2 are software configuration management, software quality assurance, software subcontract management, software project tracking and oversight, software project planning, and requirements management. Okay, now CMMI level 3, define. Okay, at this level, software engineering and management processes are documented and standardized throughout the organization and become the organization standard process. Okay, activity, roles, and responsibilities are well defined and understood throughout the organization. So the process capability of this level is characterized as being standard, consistent, stable, and repeatable. So key process areas for level 3 are peer review, intergroup coordination, software product engineering, integrated software management, training program, organization process definition, and organization process focus. Okay, now CMMI level 4, manage. At this level, quantitative metrics for measuring and assessing productivity and quality are established for both products and processes. All right. So control over projects is achieved by reducing the variability of project performance so that it falls within acceptable control boundaries. Okay. The processes of organization at this level are characterized as being quantifiable and predictable because quantitative controls are in place to determine whether the process performs within operational limits. Right? So key process areas for level 4 are software quality management and quantitative process management. Okay, now is the last one, CMMI level 5, optimizing. Okay, this is the highest level of process maturity, which is the whole organization is focused on continuous process improvement. Okay, these improvements come about as a result of innovations using new technology and methods and incremental process improvement. Right. So at this level, the organization has the ability to identify its areas of strengths and weaknesses. Okay. Innovation and best practices based on lesson learned are identified and disseminated throughout the organization. And the key process areas at this level are process change management, technology change management, and defect prevention. Okay. Okay, this is a framework for project quality management plan. All right. Basically, all project stakeholders want quality. Unfortunately, there is no commonly accepted approach for project quality management, so many project managers approach it differently. Therefore, a basic framework has been introduced to guide and integrate quality planning, quality assurance, quality control, and quality improvement. All right. So this figure illustrates a framework for the project quality management plan. This framework provides a basic foundation for developing a project quality plan to support the project's quality objectives. Okay, so before setting out to develop a project quality management plan, the project organization should define the direction and overall purpose for developing the plan. So this purpose should be grounded upon the quality philosophies and principles, right? Quality philosophies and principles. Okay, although several different quality gurus and their teachings were introduced earlier, okay, but there are several common themes as backbone for any organization plan, okay, for ensuring quality of projects, processes, and product. Right. So these ideas include focusing on customer satisfactions, okay, preventing mistakes, improving the process to improve the products, making quality by everyone's responsibility, and employing fact-based management. Right. So number one is focus on customer satisfaction. Customer satisfaction is the foundation of quality philosophies and concepts. Customers may be internal, which is individual or group who are the receivers of specific project deliverables, or external, such as the project sponsor, client, user, or paying customer. Okay, so the next one is prevention, not inspection. Okay, it is regarding the cause of quality, which involves four components, which are prevention, inspection, internal failure, and external failure. Internal failure can be fixed before delivery, and external failure can create the most damage for an organization because the customers view towards the organization, right? So prevention is the least expensive cost and can reduce the likelihood of a defect or bug reaching the customer undetected. And this will reduce the cost of development and improve the overall quality of the product or system. Okay. Okay. Number three, improve the process to improve the products. Okay, project deliverables. It is regarding the project deliverables which improving the capability and maturity of a process will improve the quality of the product. So number four is quality is everyone's responsibility. Quality improvement requires a commitment from management and the people who will do the work. Right? So quality requires the team efforts that requires quality consciousness throughout the project. Okay, so the last one is fact-based management. Okay, managing the facts requires that the organization capture data and analyze trends that determine what is the actual truth about its process performance. Okay. Okay, now project standards and metrics. Okay, this figure illustrates some examples of project standards, which is these standards can be defined in terms of project scopes or deliverables, right? Okay, standards mean agreed upon specifications or criteria to ensure that all of the project's deliverable meets their intended purpose. right? So it provides a basic for measurement because they provide a criterion or basis for comparison. Okay, for example, several dimensions can serve as quality standards for a software product, right? This includes the application's reliability, okay, usability, performance, response, all right, security, aesthetics, and maintainability. Okay, so quality metrics is a set of metrics that allows the project manager and team to monitor each of the project standards. Okay, there are two parts of a matrix: the metric itself and an acceptable value or range of value for that matrix. Okay, so metrics should focus on three categories, which are project, process, and products. All right. Okay, next is quality assurance. Quality assurance provides an auditing of the project to ensure that the documented standards, processes, and metrics defined in the quality management plan are being followed. Right. So there are three types of auditing, which are verification, validation, and testing. Okay, verification and validations are important quality assurance activities to continually prompt us to ask whether we will deliver a product or system that meets our project customers' needs and expectation, right? So basically, verification focuses on the process-related activities of the project to ensure that the product or deliverable meets its specified requirement before final testing of the system begins. Okay, which is in general, verification includes three types of review. The first one is technical reviews. Uh, to ensure that the products or system will conform to the specified requirement and the process is including walkthrough. Okay, a walkthrough is a review process in which a developer leads the team or a group of his or her peers through a program or technical design. Right. The next one is business reviews. Uh, to ensure that the product or system provides the required functionality specified in the project scope and requirements definition. Okay. The next one is management reviews to compare the project's actual progress against the baseline project plan. The management may review the project to determine if it meets scope, schedule, budget, and quality objectives. All right. Okay. Next is validation. Validation is a product-oriented activity that attempts to determine if the system or project deliverable meets the customer or client's expectation and ensures that the system performs as specified. Okay, this validation is unlike verification. Okay, validation activities occur toward the end of the project or after the product or system has been developed. Right. So the last one is the testing. Testing provides a basis for ensuring that the product or system functions as intended and has all the capabilities and features that were defined in the project scope document. Okay. It also provides a formal structure and traceable process that gives management and the project sponsor confidence in the quality of system. Right? Okay, our next topic is quality control. Quality control focuses on monitoring the activities and results of the project to ensure that the project complies with the quality standards. Alright. Okay, there are several tools and techniques used to support the quality controls activity, which are control charts, cause and effect diagrams, and testing. Okay, Walter Schwartz introduced the control chart as a tool to better understand variation and to allow management to shift its focus away from inspection and more toward the prevention of problems and the improvement of processes. Alright, so cause and effect of diagrams. Kaoru Ishikawa introduced to the use of statistical methods for quality control. Okay, Ishikawa advocated the use of easy-to-use analytical tools that included cause and effect diagrams, which is called Ishikawa diagram or Fishbone diagram. Okay, the last one is the testing, which is the basis for ensuring the product or system functions as intended and has all the capabilities and features defined in the project's scope document. Okay, this is the example of control charts for statistical control. On the left side of this chart provides an example of control chart where a process is said to be stable or in statistical control. Okay, usually variations attributed to assignable causes can create significant changes in the variation patterns. Okay, because they are due to phenomena and not considered part of the normal process, right? So an example of assignable cause variation can be seen by the pattern, okay, on the right side of this chart, right? This type of variation can arise because of changes in raw materials, poorly trained people, changes to the work environment, machine failures, inadequate methods, and so forth. Okay, therefore, if all assignable causes are removed, the process will be stable because only chance factors remain. Alright? Okay, this is the example of Ishikawa diagram. This diagram can be used in a variety of situations to help understand various relationships between causes and effect. Right? Okay, the effect basically is the rightmost box and represent the problems or characteristic that requires improvement. Okay, so a project team could begin by identifying the major causes, which is in this diagram, people, methods, management, technology, measurements, and environments. These causes may influence the problem or quality characteristic in question. Right. So each major cause can be subdivided in potential sub-causes, right? Like this one. Okay, for example, causes associated with people may be lack of training or responsibility in identifying and correcting a particular problem. Okay, once the diagram is complete, the project team can investigate the possible causes and recommend solutions to correct the problems and improve the process. All right. This is another useful tools, which is a Pareto chart or diagram, right? It was developed by Wilfredo Federico Damaso Pareto, and it became known as 80-20 rule. Okay, for example, 80% of the problems can be attributed to 20% of the causes, right? A Pareto chart can be constructed by collecting and summarizing the quality-related data by rank order of the classifications from the largest to the smallest, or from the left to the right. Okay. As you can see, the most frequent type of problem had to do with documentation questions. Right. So, in terms of quality improvement, it may suggest that the user documentation needs to be updated. Right. These are some additional quality control tools. Alright, checklists can be used as an aid to ensure things are not forgotten. Right, flowchart or process maps can be useful for documenting a sequence of steps and decision points. Alright, these tools can be useful for understanding the complexity of process in order to find opportunities to make processes more effective and efficient. Alright, okay, lastly is collection of data can provide the basis for fact-based management and statistical analysis. Alright, so forecasting using regression or correlation analysis can help identify trends and hidden relationships. Right? Okay, in order to continuous improvement, you must use knowledge management as a tool for organizational and team learning, identifying best practices. Okay, therefore, it is important that the lesson learned from the project team's experiences be documented so that best practices are identified and disseminated to other project teams. All right. So, continual incremental improvements can make a process more efficient, effective, stable, mature, and adaptable. And the last one, a project quality plan should be more than an attempt to build a product or system. All right. It should also support the organization in searching for ways to build a better product or system. Okay. I think that's all for chapter 9. Assalamualaikum warahmatullahi wabarakatuh and thank you.